Hello, greetings and best wishes. Today we're gonna learn about an ion, alright? So, actually, before we learn the definition, I'd like to, go on a little bit of a side quest, if you will. So, below, I have two little happy atoms here. I have a sodium atom and I have a chlorine atom. So I would like to ask a very, very simple question. What would happen to the charge of the sodium atom if it loses an electron? Remember? What would happen to the charge of the sodium atom if it loses an electron? And what would happen to the chlorine atom if it gains an electron? So think of my questions very carefully, then I'll go into a little explanation of, why we're doing this and stuff. Alright, so my first question was what will happen to the charge of the sodium atom, if it loses an electron? That was my first question. So what will happen to the charge of the sodium atom if it loses an electron? We have previously learned, thinking of a good color here. Okay, so we've previously learned that the number of protons is equivalent to the number of electrons. And because the number of protons equals the, actually, before we do that, we need to remember what the charges of a proton and an electron are. So, well, a proton, let me actually do this here. Let's do it side table. Subatomic particles. And then we have particle and charge. Okay? Apologize for the bad drawing here, but we're gonna have to make it work. So, if we have a proton, its charge is going to be positive, and if we have an electron, its charge is going to be negative. So therefore, as the number of protons is equal to the number of electrons, there's gonna be no charge. Let me show you. So I'm gonna use, so for sodium's case, I'm just gonna use P and E to represent protons and electrons. So sodium, let me just write this down. We have maybe on the side here, Na, and then sodium has 11, sodium 23. I hope you can see that. Yep, you can. So Na, sodium 23. If you recall, The top number represents the number of protons it has. Top number represents the number of protons that it has, right? The top number represents the number of protons that it has, and the bottom number is just its mass number, which is not relevant for what we're doing right now. Okay, so as the number of protons is equal to the number of electrons, so we can come up with this equation that P is equal to E, right? Ignore the minus sign, that's so they represent electrons in chemistry. What's the total charge of the protons? Well, it's just gonna be plus 11. And what is the total charge of the electrons? What is the total charge of the electrons? Sorry, wait. This is going a bad place. Okay, wait. Charge of atom, sorry. Charge of atom is equal to protons, number of protons, plus the number of electrons. Alright, okay, sorry for the little error there. Okay, so the charge of an atom is determined by the number of protons versus the number of electrons. So we can therefore determine the charge of sodium to be is equal to, well, how many protons does sodium have? Well, sodium has 11, so that would give you a positive charge of 11, plus the number of electrons. Remember this top equation? The number of protons is equal to the number of electrons. So therefore, it has 11 electrons as well, but those electrons will equate to have a charge of negative 11. Because there's 11 electrons, each of them have a charge of negative, so the total charge of the electrons is just going to be negative 11, right? So, well, 11 plus negative 11, that's just going to be 0. So the charge of sodium is 0. And it's going to be like this for every atom, because for every atom, it has the same number of electrons as protons, or vice versa. But remember, what will happen to the charge of the sodium atom if it loses an electron? Well, if it loses an electron, we can come out with this formula of number of electrons is just going to be equal to 11 minus 1, because it lost an electron. So it's going to have 10 electrons. So now let's figure out what will happen to the charge of this sodium atom after it has lost an electron. So we can go back to this original equation. Charge of an atom is equal to number of protons plus the number of electrons, right? Along with their charge. So basically the charges of protons plus the charges of electrons, right? So the charge of sodium after it has lost an electron, how many protons does it have? Well, the protons are not affected, so it's gonna have the same charge. The protons are gonna have the same charge, positive 11. But how about the electrons? Well, since we've lost an electron, it's gonna be minus 10, right? Because each electron has a charge of minus 1, and we only have 10 electrons, so minus 1 times 10 is gonna be negative 10. So this is the total charge of electrons, total charge of electrons, total charge of protons. Okay, so the charge of sodium Well, it's not going to be neutral anymore. It's actually going to be +1. And this is what is known as, this is what an ion is. An ion is atoms of the same element that have the same protons and neutrons. Let me put this down. Same protons, same number, of protons and neutrons, but have a different number of electrons. Sorry for the long wait, I don't exactly write the fastest. Okay, so now we know what an ion is. It's an ion, the same number of protons and neutrons. Those values don't change, but with a different number of electrons. Therefore, actually, in an ion, mass remains the same because mass is determined by neutrons plus protons, and electrons are negligible, so the mass remains the same. The only thing that changes are the number of electrons, and because of that, the charge of the atom. And let me just show you how to write this. So for this particular atom here, or for this particular ion, it has a charge of +1. So what you're gonna write is you're just gonna write Na. You're just gonna write Na plus. That's how you're gonna write this ion. Okay. Na plus. You do not. A general rule in chemistry is that if it's like a value of 1, you don't need to write that. Okay, you don't need to write that. You just indicate this plus, right? If you wanted to do it in nuclide notation, you are gonna go, I believe it's gonna be 2311, I believe. If my chemistry knowledge hasn't betrayed me, that's gonna be correct. Give me 1 second. Yes, okay, yep, that's correct. So if you wanted to write that in nuclide notation, it's just going to be 2311 Na+. Okay, I'm not sure if you can write it in like that, right? I'm assuming you can, but not sure. Not sure if you can write it in nuclide notation. I'll have to check later, but I think it should be fine, but just check your textbook if it allows you to do that. But anyway, just they don't really need you to write in nuclide notation anyway, so just write it as Na plus for the ion, okay? Na plus. So if it gains 1, or if it's a 1, you don't really need to write that. It's not wrong to write it, but just to save time, and it kind of makes you look like an amateur if you write +1. I mean 1 plus on top of it. It signifies you're a beginner. Nothing wrong with that though. But yeah, you don't need to write +1 or -1, whatever. Okay, so the last question for today is gonna be, what will happen to the chlorine atom if it gains an electron. Oh, by the way, sorry, it's what will happen to the charge. Alright. Bad English, but it's fine. This is chemistry. Okay, so we can just, you know, use this formula here. Charge of atom is equal to protons plus electrons. The charges of that, the total charge of protons plus the total charge of electrons. So let's just write that down. Charge of chlorine is equal to protons plus electrons. Total charge of protons plus the total charge of the electrons. Okay, so now we need to know the values of our chlorine atoms. So it's gonna be Cl 17 chlorine 35.5. So remember, we don't care about the mass number of chlorine, we only care about the number of protons, which is the top number. It's 17 protons. And as we know, the number of electrons, the number of protons equals the number of electrons. So it's also going to have 17 electrons if it hasn't gained an electron. But since it has gained an electron, the number of protons is just going to be 17 plus 1, because remember, the number of protons is equal to the number of electrons, right? So 17 equals 17, and since we've gained an electron, the number of electrons are going to be 18. So let me write that down. Number of electrons. Remember, this is not the charge, this is just the number of electrons. You need to be quite careful with this. So number of electrons is equal to 17 plus 1. Remember, this is equal to that. Proton number, electron number, plus 1. That's just going to be equal to 18. Alright, so now we can sub in these values into this equation to find out the charge of chlorine. So charge of chlorine is equal to how many protons do we have? Well, we have 17 protons. 17 plus 17, right? This is the charge, remember. Plus how many electrons do we have? Well, we have 18. So the total charge of the electrons is just going to be minus 18. And then so the charge is just going to end up being minus 1. Minus 1. It's gonna be a negatively charged ion. For the sodium, since its charge is positive, it's just gonna be a positively charged ion. So a general rule of thumb is that if an atom gains electrons, its charge is gonna be negative, and if an atom loses electrons, its charge is gonna be positive. All right. So if we would like to write this down, so it's just going to be Cl minus. Remember, we don't have to write the 1. You could do that, but I don't see a point. All right, Cl minus. That's going to be our little thing. Also, before we end the video, general rule of thumb, nonmetals gain electrons. Electrons to form negative ions. Metals lose electrons to form positive ions. To form positive ions. And you are going to learn this in ionic bonding, that these two will transfer electrons to each other, and these actually form your table salt, NaCl. So the more you know about chemistry, you know what I mean? Lovely subject. Anyway, it's getting late. This video is getting long. I would be surprised if your attention span is not on a knife edge by now. So I'm gonna leave it here. I hope you found this video useful. First priority, I hope you found this useful. I hope you understand ions. I hope you understand how they work. And I will see you in the next video of chemistry. Have a good one.